Finally, we can encapsulate the entire distribution in a formula. For this specific example, the probability function is given by fx is equals to 2 minus modulo x minus 1 divided by 4 for x equals to 0, 1, 2. So let's verify its accuracy by substituting each value of x. For x is equals to 0, f0 equals 2 minus modulo 0 minus 1 over 4. This is 2 minus 1 over 4, which equals 1 over 4. For x equals to 1, f1 equals 2 minus 1 minus 1 over 4. This is 2 minus 0 over 4, which equals 2 over 4, or 1/2. For x is equals to 2, f2 equals 2 minus modulo 2 minus 1 over 4. This is 2 minus 1 over 4, which equals 1 over 4. Therefore, the formula perfectly reproduces our probability distribution. For any function to be a valid distribution, two rules must be satisfied. First, each probability must be between 0 and 1 inclusive. In our table, 1/4, 1/2, and 1/4 all satisfy this. Second, the sum of all probabilities must equals 1. 1/4 plus 1/2 plus 1/4 equals 1. Our distribution is valid. There are many practical problems where this cumulative perspective is more useful. For instance, rather than asking what is the probability that a salesperson makes exactly 5 sales, a manager might be more interested in knowing what is the probability that a salesperson make at most 5 sales. Or what is the probability that the number of defective items in a batch is less than or equal to a safety threshold. So this leads us directly to the concept of distribution function, also known as the cumulative distribution function, or CDF for short. Formally, we define it as follows. The probability that a random variable x is less than or equal to some real number x is written as f of x equals the probability that x is less than or equal to x. This function, denoted by the capital letter F, is what we call the distribution function or the cumulative distribution function of x. We now introduce a related concept, the cumulative distribution function f(x). This function gives the probability that x is less than or equal to a specific value x. Formally, f(x) is equal to probability x less or equal than x, which is equal to the sum of ft for all t less than or equal to x, where ft is the value of the probability distribution of x at t, is called the distribution function or the cumulative distribution of x. The cumulative distribution function has key properties. F negative infinity equals to 0, f infinity equals to 1, and it is a non-decreasing function. If a is less than b, then fa is always less than or equals to fb. Let's work through a detailed example. Find the cumulative distribution function for the random variable x with probability function fx is equals to x over 15 for x equals to 1, 2, 3, 4, and 5.